Welcome to another episode of Legitimate Matters. I am your host, William Parris. If you've been keeping up with Legitimate Matters, you know that we've had such amazing shows over the past couple of years. We've talked about so many different topics, including politics, and there's so much controversy in the United States these days, controversy in politics. And one controversial topic has been climate change. Well, my guest today is a repeat guest and a friend of Legitimate Matters. Dr. Rick Smith, who is a scientific consultant, spoke to us about climate change in 2 episodes that we did previously, and I'd like to welcome Rick back to the show.
Thanks, William. It's nice to be here again. It's great to be on your show again.
Absolutely.
Fantastic.
You and I have had great conversations in the past, and I can talk to you for hours. But for those people, the viewers who did not catch the previous shows, and if you haven't caught the previous shows, shame on you, but you can go to legitimatematters.com and see those. But tell us about Global Aquatic Research.
So Global Aquatic Research is a scientific research company. We are essentially a network of scientific consultants and laboratories, and we specialize in the aquatic sciences. So we work with municipalities for local environmental problems. We work for universities, and essentially what we do is we handle research projects that are within our kind of domain of specialties. We're all experts in our field. We're all practicing scientists, except that instead of working under the umbrella of a university, we're independent. So we do everything from planning a research project, analyzing samples, to working up data in writing reports. And it's everything from the global scale, looking at things like climate change feedbacks and the carbon cycle, all the way down to local environmental issues.
When someone says the word or they hear geochemical research, how would you define geochemical? Someone might hear that and not be 100% sure.
So the word geochemical is kind of a mix between geology and chemistry. So really it's the study of the chemistry of rocks. But really it's expanded beyond that, and it's really how organic molecules or inorganic compounds cycle through the environment. How they cycle through the biosphere, how they cycle through the geosphere, and through the cryosphere, which is all different forms of water on the planet. So it's looking at the Earth and chemistry as a whole.
Now, someone watching this show is going to say biosphere and all of the different terminologies, but basically we're talking about the atmosphere.
Yeah, and of course the atmosphere is part of it. So we tend to compartmentalize things. The biosphere would be essentially anything living on Earth.
All right.
So it's the interaction of biology in our atmosphere, in our waters.
All right. Yeah. So it's the study of the water, and tell me more about that. The water.
So one of the things, my really specialty is looking at Earth's carbon cycle. We know Earth's carbon cycle is important because we see rising carbon dioxide concentrations in the atmosphere, and that's causing global warming. But there's carbon in all sorts of other forms. I mean, we know that we're made of carbon, and all living organisms are made of organic molecules that contain carbon. But there's carbon in the water. There's a lot of carbon in the ocean. There's carbon in sediments of the ocean. There's carbon in soils. There's carbon locked up in forests. And those all have these interactions between each other. And it's important to study the flow of carbon through those systems when we try to look at what's going on in the atmosphere and what's going on with our climate.
And over the past year, certainly since you were on the show, there's been a lot of changes that we saw in 2018. Share some of that.
2018's been a really interesting year. To start off, it was the 4th hottest year on record, global average temperatures, which puts it as the 4th year in the row that we've broken the record.
The 4th year in a row?
The 4th year in a row.
Oh, wow.
Yep. So 2018, 2017, 2016, and 2015 were all had the hottest global average temperatures on record. We saw 2 massive wildfires in California, and in fact, just in the last several years, California's had 3 of its largest wildfires. this year, California saw about 2 million acres burned by actually, we know about the bigger wildfires, but there actually were over 8,000 of them this year.
Well, I want to talk about the wildfires in California, but I want to come back to that.
Yep.
But with the this being the fourth record-breaking temperatures or heat rising, help me to say that, in the past 4 years, this is also going to affect rising sea levels.
That's right. So the most interesting thing about the science of climate change and sea level rise is that our methods are getting a lot better.
Okay.
Computing power is getting more accessible and cheaper. Our models are getting better. There's some huge reports that have come out recently, the National Climate Assessment, and the IPCC just put out a special report where now we can actually look at what's in store for us if we stop all fossil fuel emissions over the next 10 years versus 20 versus 30.
Okay.
What's going to happen if we keep global temperatures at 1.5 degrees Celsius above average versus, say, 2 degrees or 5 degrees Celsius above average. So right now we have more information than we've ever had about how climate change is going to affect us and what we can do to stop it. So there's been a lot of interesting science going on this year as well, in addition to continuing to monitor these extremes. We also had Hurricane Michael, which was the fourth strongest in terms of winds to ever make landfall in the Atlantic coast. Yeah, well, it hit the Florida Panhandle. So
You mentioned IPCC.
Yep.
What is that?
IPCC is the International Panel on Climate Change.
Okay.
It's commissioned by the UN, and they put out a report every 5 years, and these are massive reports that bring together all these different aspects of science to put out the most relevant, up-to-date information on climate change.
So we're talking about now all of this new information, new facts, new studies, and it seems like 2018 has been really groundbreaking in terms of new information.
Yeah, absolutely. It really has. And so what we've been learning really, the most important point that's come out of this year is that we've got about 12 years.
Oh.
This coming decade is going to be the decade where we do something or we don't. And now we can actually start to narrow down what the consequences are going to be of not doing anything over the next 10 years. And what we now know is that the changes that we need to make to everything we do, to our lives, to our infrastructure, to our industries, to our power generation, everything needs to transform incredibly rapidly in the next decade if we're going to mitigate the worst effects of climate change. That's what these reports are telling us.
Wow. So that's really an eye-opener. And to me, what I'm hearing you say is that while we are talking about so many other issues that are taking place in the United States, of course, we don't have to talk politics because we know how volatile and really out of control that is. But one thing that I don't really hear that often is the dangers and the direction that the planet is going in terms of climate change. I'm listening to you today on this show, and I find it quite alarming that mainstream media and the government is really not emphasizing the changes that we have to make. I still see people doing certain things that are detrimental to the planet, but there's just not enough being done to steer us in another direction. We're going to go to break, but when we come back, let's talk more about some of the IPCC reports and other things that you have discovered. I want to talk about Greenland also when we come back after the break. Don't you dare change that channel, because this is a great conversation with my guest, Dr. Rick Smith. We're talking about climate change. This is a story you don't want to miss. We'll be right back. Welcome back to Legitimate Matters. Once again, I'm your host, William Parris, speaking to my very exciting guest, Dr. Rick Smith, and we're talking about climate change. Rick, in the last segment, we were talking about the IPCC reports and the sobering statistics, that have been discovered or have come up in 2018 and certainly over the recent years. What are we talking about? You mentioned that if we don't make certain changes within the next decade or so, that it will be irreversible. Help us to understand what changes that you are referring to and what can we do about it?
So a big part, the biggest uncertainty in understanding what's going to go on in the future with climate change is human behavior. Are we going to start to move towards renewable energy? Are we going to start to change our modes of transportation and our industries and make them more efficient and things like that? So we have all these different tracks that we're projecting based on changes that we make, which is why we're talking about this kind of thing. So far, we've tracked along the worst case scenario, but we're hoping to change that. The scale of these changes is tremendous. What these reports tell us is that everything about the way we live and everything about the way our entire society needs to change. It has to be drastic, or we're going to see some major consequences within our lifetime that are going to increase exponentially after that as well.
Give us some examples of those changes. What do you mean?
That would be nearly completely weaning ourselves off of fossil fuels and completely going to renewable energy like solar. Fortunately, solar's been getting cheaper, so there are some good things that's happening. The other things we need to develop, we need to put more money into research and rapidly, because this needs to happen quick, into being able to capture carbon dioxide in the atmosphere and store it in some form. Right now, we don't have that technology at scale, but all the scenarios in the IPCC report where we don't see the worst effects of climate change assume that we're going to be able to capture carbon dioxide from the atmosphere and store it somewhere.
When we capture the carbon dioxide and we store it, then how is that helping us?
Because right now, climate change is driven by the huge amount of carbon dioxide that we've pumped into the atmosphere. So fossil fuels are essentially really old carbon-containing organic molecules that have been produced by algae in warm, shallow seas millions of years ago. And that's carbon that's been locked and stored deep in the ocean and eventually in rocks. And then it migrates out of there and becomes, say, an oil reservoir or a natural gas reservoir. So what we're doing in the blink of an eye on a geological scale is taking that material and combusting it for energy. We're essentially gaining the energy that's been locked up in these molecules as those algae were photosynthesizing. We're using them for our own energy to fuel our cars, to fuel our industries, and it pumps carbon dioxide into the atmosphere. We should be at about 280 parts per million right now, and right now we're at about 410 parts per million. So because carbon dioxide is driving the climate change that we see, we need to start removing it from the atmosphere.
Okay, and now the changes that we would make would be in, as you said, the cars that we drive. That's going to the electronic cars as opposed to no gas, battery operated.
Yeah, we need batteries are a big part of it. We need more efficient and better ways to store energy long term. Transferring over to electric is a really good idea, but it depends on where we get our electric from too. If we're getting our electric from a coal-fired power plant, it's not going to help us out.
You see, we can just this conversation, Rick, can go on and on because there's different directions that you can take in addressing some of these problems. But if we don't come up with at least a game plan, whether it's 10 bullet points or so, then what are we at risk of? What are the real honest dangers that we can expect to see, I would say, within the next 50 years?
In the next 50 years, we're going to see, here in New York, we're going to see many more days in the summer that reach above 90 degrees. We could see as much by the time we're in our 70s or 80s, we can see as much as a few dozen days over 90 degrees in the summer, and we're only used to maybe a few at most. We could see the ocean creeping up along our coastlines. By the year 2100, we can see as much as a meter of sea level rise, which is going to devastate a lot of coastal zones, especially lower sloping ones where that water just creeps up every little bit that it rises.
Miami comes to mind, certainly the lower part of Florida.
Yep, and here it would be parts of Long Island and Queens, a lot of the lower lying areas. So we're going to see stronger, more frequent storms. We're going to see more wildfires across the U.S., and we're going to see billions upon billions of dollars that it's going to cost us to be able to do reconstruction after wildfires and after stronger storms that we're going to see. So it's going to cost us.
So now, with all of that said, I've been reading reports and on the internet, and I catch snippets on the news about the glaciers in Greenland melting, and that seems to be a crisis, and I don't think that that's getting enough press. What's happening in Greenland?
Greenland is continuing to melt. I know we talked about it a little bit last time, but there's 7 meters or a little over 20 feet of sea level associated with the ice sheet on Greenland. So if that were to all melt, we would see our ocean increase in height by over 20 feet.
Wow.
And it's turning out that it looks like we're almost already past that point to which Greenland will eventually melt. It's going to take hundreds of years because there's a lot of ice there, but it's eventually all going to go unless we immediately reverse what we're doing to the Earth right now.
You know, when you say it's continuing to melt, eventually it will melt. It will take hundreds of years. I could see someone sitting here and saying, or watching the show and thinking to themselves, "Oh, hundreds of years. That's way down the road. We'll all be dead and gone, and nobody cares." But I would say that from this conversation, that our lives are still going to be affected within this lifetime. And if you're watching and you have children, certainly your children, and even more so your grandchildren, will certainly be impacted by what we're talking about today on the show.
Yeah. The other thing is, it's really important to stress that we are seeing really terrible effects of climate change right now. 1/5 of all the world's coral reefs are already dead. That includes the Great Barrier Reef, which is about the size of Italy, has had bleaching events year after year, which is where essentially coral, not to get into it too much, but coral lives symbiotically with algae, and when water's warm, these algae leave and the corals die, especially if this happens year after year. In our lifetimes, we're almost certainly going to lose almost all of the world's coral reefs.
In our lifetime.
And in our lifetimes, and that is a catastrophic change to the planet and to the oceans. 25% of all marine species in the ocean depend on coral reefs is part of their habitats. So I know we talked about in the last show a little bit, but we get 50% of the oxygen in our atmosphere from the ocean. So massive ecological shifts in the ocean can result in big changes to things like human health.
Wow. You know, when you say 5% of our coral reefs have disappeared.
20% already.
20%,
one of 5. Yeah.
Wow. Well, when I think of that, you know, people think, oh, it's so beautiful. You look at the ocean, you're swimming and you're diving, and you think that it's gorgeous, but you're not really thinking about how the disappearance of the coral reefs will actually affect sea life and our own personal health.
Yeah. And they're arguably the most important ecosystem in the ocean and probably on the planet.
Wow.
And they'll almost certainly be dead, at least 99% of them in our lifetimes, which is catastrophic and essentially heartbreaking.
Wow.
I mean,
well, again, we can talk forever, but we're going to take a break right now. When we come back, I want to touch more about those wildfires in California, because I never really made the association between climate change and wildfires. I don't know if you did, those who are watching, but if you didn't, stay tuned. You're about to find out. Legitimate Matters, William Parris. We'll be right back.
I don't want to give trillions and trillions of dollars. I don't want to lose millions and millions of jobs. I don't want to be put at a disadvantage.
I wish you could go to Greenland, watch these huge chunks of ice just falling into the ocean, raising the sea levels.
And you don't know whether or not that would have happened with or without man. You don't know.
Well, you're scientists at
No,
NOAA
we have
and NASA.
scientists that disagree with that.
You know, I was thinking, what if he said, no, I've seen the hurricane situations, I've changed my mind. There really is climate change. And I thought, wow, what an impact. What an impact that would make.
I'm not denying climate change, but it could very well go back. You know, we're talking about over
that's
millions of
denying
years. They say that we had hurricanes that were far worse than what we just had with Michael.
Who says that? They say. You mean the people on the phone?
People say that in the...
Yeah, but what about the scientists who say it's worse than ever?
You'd have to show me the scientists, because they have a very big political agenda, Leslie.
I can't bring them in.
Scientists also have a political agenda.
Welcome back to Legitimate Matters. This is William Parris, once again speaking to my guest today, Dr. Rick Smith. Rick, we were talking about previously on the show about the wildfires in California. There are some people that make the association between climate change and wildfires, but I don't believe that every viewer understands really how these massive wildfires that we're seeing and people losing their homes and people losing lives, how is this associated and connected to climate change?
So I think it's first important to know that the frequency and intensity of wildfires has increased, especially in the last few decades. Since the 1980s, we lose about 1,000% more acres to wildfires in the U.S. every year. And it all has to do with, to get a good fire going to burn, drier conditions are essentially what fuels it. So in California, there are natural wildfires. And so part of it is forest management and part of it is climate change. The forest management aspect is we're supposed to naturally allow smaller fires to burn. Some of these ecosystems are dominated by fire, and they're not supposed to burn the tall, mature trees. They're supposed to burn all the underbrush. But what happens is when you start to get people moving into more woody areas, you tend to put out those fires before they start burning down people's houses, and all that brush and all that fuel builds up. Superimposed on top of that, you have climate change where you have drier conditions. In California, you get most of your rainfall and most of your precipitation either in the form of rain or snow in the fall and in the winter, and then conditions get drier throughout the summer. For every degree temperature increase that you have, you're going to have much drier conditions during the fire season, which is allowing these fires to burn with much more intensity.
So what I just heard you say is that there are small good fires, and then there are bad fires and the ones that are out of control. But there is a purpose for fires that are controlled to some degree.
Yeah, and I think they're starting to realize that more in terms of managing forests, that they're supposed to do controlled fires, which is where it essentially removes all the fuel so you don't have these super large fires burning. Now when we're talking about drier conditions because of hotter temperatures and precipitation shifts, so we get less precipitation in these areas, we get hotter temperatures, so things dry out more by the end of the summer, and now, especially since we have more fuel, because we haven't been having these smaller wildfires, we get really large destructive fires that kill dozens of people and cost billions of dollars.
With all of this happening, why don't we see, or do you have any idea why we don't see more reports and why the important work that you do is not making its way to mainstream media? Is there some place we should look? Is it out there and we're not paying attention? What's your thoughts on that?
You know, that's a really interesting question, William, and one that as scientists we've been asking ourselves quite a bit recently. We spend so much time in the lab, so much time reading reports, so much time writing technical reports that I don't think we've spent enough time doing outreach, communicating our thoughts and these things that we're studying in some sort of in some sort of way that we can get people to see these kinds of interactions across all these different segments of the environment that we're talking about, and how this is all built into how we're changing the Earth through pumping CO2 into the atmosphere. So right now we're talking a lot more about trying to do outreach through education, through public speaking, and I think that's the component that we need. But the other side of that is somehow climate change has become a politically charged issue.
Right.
And I think it's important to understand that this is the same science that has given us everything else in this world in terms of technology, in terms of our understanding of biological systems and the environment. Nothing has changed. This is a giant body of work. The last IPCC report referenced 6,000 individual studies and had 100 of the best scientists across the globe contributing to these reports. So we somehow need to take these volumes of work and distill them in a way that we can give people an easy idea to understand what's going on and how they can make changes in their own life. And so I think we are partly responsible for that as scientists, and we need to focus on that more.
What about those of us, certainly viewers, myself, who are watching this? What can we do? Because it's one thing to say that we need to have more technology to address this, but if I'm not working in that particular field, and if I'm not pushing, writing the bill and passing the law and making these changes, what steps can we all take to be involved, and where can we look to pay attention and to become more educated in something so important?
Yeah, so I think on that note, it's important to understand that this situation is going to take a concerted global effort of everybody involved, because these changes we need to make to the way we live are so drastic. That's why you're going to be seeing politicians or people in the media calling for these really big changes, because that's what we know is required of us to mitigate the worst effects of what we're going to see. What we can do individually is to, one, we be as educated on these issues as possible, and I think that's where we come in as scientists, right, in terms of helping with that outreach. Secondly, get involved in local environmental organizations, get involved with local politics, or even politics at a larger scale, because this is going to have to come. This is the changes that we need are so big that it's going to have to come from the top down. Most of us already make environmentally positive changes to our lives. We don't litter. If we can, we drive less, or we buy more fuel efficient vehicles. But we're now talking about changing the way industry is done. So we just need to be screaming from the rooftops, right, that this is what we need. We're all going to band together and do this, because we don't want to leave our children and our grandchildren with a world that is extremely different than the way we've been living.
Well, it sounds to me like we need to hold our local, our elected officials accountable for paying attention. While we are focused on so many other things, I think that it's criminal to overlook and not pay attention to something as important as climate change. And if you can tell us, maybe in 30 seconds as we close the show, how your efforts will continue, specifically as a consultant in your area.
Yeah. Mm-hmm. So my responsibility as a consultant is to perform the highest level of research that I can.
Okay.
Because it's all those individual research projects that are conglomerated into these larger reports that really push the issue out there and show what's going on. So as a scientist, I need to remain true to the scientific method, scientific principles, and do the absolute best technical work that I can. And then that needs to scale up to societal change. And I think the big part is when people trust the science that we're putting out, there's a much larger chance that we're going to get the kind of change that we need.
Wonderful. Rick, it was great having you on the show. As you and I both know, you and I can talk for hours, but for those of you that are watching, I want your takeaway to be that climate change is real. These are things that we should pay attention to. Legitimate Matters is not mainstream. Legitimate Matters is about what is relevant. It's legitimate. And these are the things that do matter. They matter to me, and they should also matter to you. Thanks for watching Legitimate Matters. Rick, thank you so much for being on the show. Tune in. We look forward to seeing you the next time on Legitimate Matters. Rick, thank you.
Thanks.